3 runs in the first inning and still lead 3-0 over Colorado, bottom of the 4th. The Twins have taken their early 1-0 lead. It's now 5-0 at Oakland in the bottom of the 6th inning. The Dodgers at Washington game was suspended after 5 innings and 3 lights outages at Nationals Park, an AC problem in D.C. Washington leading the game 3-2, leading in light outages 3-0. It'll resume the game tomorrow, 2 p.m. Eastern Time, and the temperature is expected to be 90 degrees there with a chance of rain.
Big Steve in the weekly top 40. Checking your reflection and telling your best friend, like, girl, fix my fucking bed.
There is I probably should continue this for a little bit on Monday, just to finish it off. But the result of the index theorem, let me just write down the answer, but I think to be fair, he will have to invest a little bit of time on this on Monday. The result of the index theorem is that this is equal to that. So the index of some operator O acting on some field phi that interacts with gauge field is given by the integral of a characteristic polynomial associated with that operator, truncated at the 2n term of that polynomial. So you give me some function of omega that is associated with this operator. That's one example for the Dirac operator. If you give me that, I've got some horrible function, but I'll expand it as a series. The 2n term in the series, in other words, the form in the series that saturates the dimensionality of the manifold, you integrate that, and that turns out to be the index associated with that operator. So I think maybe I was hoping to finish this off today, but there was a bit more time of the effectiveness stuff than I thought there would be. So would you want me to spend the first half hour on Monday finishing this off? But we'll get to instantons next week for sure on Monday. So I'll spend the first part finishing off. Yeah. It means this operator is that operator. So in other words, this polynomial will be associated with this operator in a way that I have not had time to flesh out because we're out of time. So that's what I want to do on Monday. In the case of the Dirac operator, I would write P of P slash of F was trait of F F. Right. What we've been doing all along, O is the T slash operator, F is the gauge strength, and it turns out this is equal to that. So all that this subscript means is this polynomial has to be meaningfully associated with this operator O. I mean, I can construct other gauge polynomials of field strength, but they're not necessarily associated with the anomaly. That P is a special case of P over there. Well, no, it's not any polynomial function. It is a particular polynomial function that is associated with this operator in a way I haven't had time to spell out yet. That's the whole point of this function. So how it's associated with it, I'll give some examples of that. But in some sense, the object of the gauge, when looking at it from this viewpoint, is if you give me an operator, an elliptic operator, and a manifold on which I can meaningfully define a left-handed and right-handed field on which that operator acts, that index will be associated with some index of that operator will be associated with some particular polynomial that has to be specified according to some document. So, as I say, I jumped ahead about a page just to show you the bottom line, but I haven't shown you how to get to the bottom line. That if you give me another half hour, I do it, but I do it on Define this quantity omega t to be this, where omega t is equal to omega naught plus t of omega 1 minus omega naught. So omega t interpolates between two connections where t is a parameter that goes from 0 to 1. Then one can show that d by dt of a characteristic polynomial of degree m is equal to m times d of the symmetry of omega 1 minus omega naught of omega t to the m minus 1. And this thing I can call Q of 2m minus 1. And it will depend on omega and omega t. So I can choose omega naught equals 0 for simplicity. What I showed last time, actually maybe I want to do that next. So I showed before that the characteristic class is a topological invariant in the sense that the integral of omega 0 over a manifold is the integral to omega 1 over a manifold. The difference between, it's found by integrating this equation, and the difference between them is the two q's, but by Stokes' theorem that will vanish. So the integral of over m of p of omega is the topological invariant, and one can rewrite this thing. This is called the Chern-Simons form. And it, q2m minus 1 is equal to the integral of m over t, or m times the integral, sorry, of dt, of the symmetry of omega with this curvature m minus 1. So it's a generalization of what we looked at last week. And one can show that the variation of this object, the gauge variation of this object, is equal to m times m plus 1 times this integral here,